So what do you mean by data wrangling dynamics? What is the meaning of data wrangling? What is the meaning of data wrangling? Any thoughts? Any particular idea about the word wrangling? What does it mean? Have I talked about this earlier? What is wrangling? What do you mean by wrangling? So it's also called as data massaging, not the massaging that we know. It's actually about changing certain patterns in the raw data so that we can use it for analysis. Now let's look at the data wrangling dynamics. Okay. So basically, when we want to extract information from data, when we get the raw data, we have, let's say, maybe the dates and the time of a particular incident, the names of certain people, maybe the value associated with that, it can be the profit, whatever. So there can be many reasons that we need to capture in the data. We need to extract value from data. Value doesn't mean a number, it's the value of data. So for example, if you have your banking statements, your credit card statements for the last 15 years, for example, you can think about how your patterns have changed. Maybe back when you were like, I don't know, 23, 24, you may be spending a lot of money, credit card transactions on maybe hotels or going out for coffee shops and all the other things and movies and all. When you become 30, maybe most of your expenses would be fuel expenses, vehicle expenses. If you have kids, you have different types of expenses, right? So extracting value means you try to extract the idea of data, the insight of data. So that can be near-term value as well as long-term value. Now, near-term value means, if you read the sentence, it says, what happens at the moment you likely have a sizable list of questions that you want an answer, like are people really shifting toward interacting with us through their mobile devices? So if you think about a website, for example, you create a website or a platform, maybe you are selling some items, some product. So what you need to know is whether the people are actually coming to our website or are they using our mobile platform. It's a near-term value, something that you have to understand today itself, at this instance, which is the most preferred application. But there is a long-term value as well. The long-term value is, if you read the sentences, can you use it to forecast important seasonal changes? Now, the insights that you gain from data can be taken to understand, like if I have a hotel, for example, if I have a lodge or something, maybe people come a lot during the school holiday time, and we can expect that in the next year's holiday time, there would be more people coming in. So I need to prepare more space for them. Or we can have maybe like chalets kind of things, or have ACs repaired, if it is in maybe Nuwara or somewhere, to make sure that the hot water is available, right? So in most cases, you can see when the demand goes up, you go to a hotel in Nuwara and they say that there's a hot water, but you don't necessarily get it, because they are not prepared for that amount of increasing demand. So there's a near-term value, which is like quickly knowing what is happening, and also there's a long-term value to understand the patterns and forecasting what is going to happen. So when we talk about wrangling dynamics itself, we try to extract the short-term values as well as these long-term values. It depends on the question that you want to answer, right? And we want to extract value direct and indirect as well. So what is indirect value? Data provides value to your organization by influencing people's decisions on inspiring changes in process, like risk modeling in the insurance industry. Indirect value can be nowadays what you see. Now you can see the heat is increasing. Now if you are in like electronics markets, now you need to invest more on like intelligent ACs, things like that. So that's an indirect value. Like if you can, maybe portable ACs, if you can bring some affordable ACs to people, then you have a high market demand. There should be a market demand very quickly. So it's an indirect value, but what you are extracting is how the temperature is changing. For example, the building comfortable levels inside the buildings. So if you get this value, that's an indirect value, but it has your business requirements. And there's a direct value, of course, like the Netflix recommendation system or YouTube's recommendation system, or even if you like, for example, let's see, you have a hospital like Asiri hospitals or Lanka hospitals. If you know that a certain set of people, when they get a ticket, let's say if you have a system like in a pharmacy kind of a system, that you take a ticket and then based on the ticket you will be directed to certain physicians or dentists. Like think about MediHealth, for example. When you go to MediHealth has a lot of doctors who are not resident doctors, right? So they will be there, and you can basically go in and then get whoever the doctor there is, then book and go. So if you analyze the data, if you are in the MediHealth industry, you analyze the data, you might get some idea that if you can simply get their mobile phones and the profession, maybe the mobile phone plus the other details like the sex and the age of birth, the date of birth, etc. So you can get some sort of a direct value to understand who are the people that are going to come maybe after 4 p.m. Who are the people that are basically coming in Saturdays and Sundays. So based on that, you can maybe demand the doctors as well. So you can have a higher value in this particular date range. So that can also be there, like the booking time. I don't know how their pricing changes, but these are some of the direct and indirect values that you can get. Sometimes it's very easy to understand direct values, like in the case of YouTube or Netflix, but also at the same time there can be other direct values as well. Like if you take a look at if you have handled people coming to an exhibition, like in the case of like University of Moratuwa, for example, we have an exhibition. So in the exhibition you find a lot of people entering, but we don't know where they are going. So we have a direct value if we have an idea about who prefers which stall, so we can minimize the traffic there. So that's also a direct value. And we have direct, indirect values, short-term, long-term values, and what makes it difficult to achieve all these things is the time. Because if, for example, like you see that when you drive, you see people making choices in front of you, right? Some people put the signal light to the right hand side and then turn it to the left. So the time it takes, for example, until you think that this person is going to turn to this side, and you stay behind them maybe for 1 kilometer to only to notice that that person is going to turn to the left hand side. So that's time, right? There is a time lag in the decision that makes it difficult for us as well. Or if you are in an industry or a business, it makes it very unprofitable, right? And also when it comes to extracting value from data, the time it takes for processing data is also something that we have to think about. If you have the latest computers, latest cloud devices and all these things, but it takes a lot of time. Now I'm sure you are using Claude or ChatGPT or Copilot. You know that during the rush hour or times where you have a lot of requests, sometimes they go down, right? Sometimes it takes a lot of time to get a response. So that time is a problem. To analyze data, to process data, it's a problem. So when all these things that we discuss in our lectures or in day-to-day life, it depends on the energy that we have and the time it takes for certain decisions. So sometimes it's important to get a particular decision quickly or more quickly than the other to optimize your operations, right? So that's why I said if you have certain decisions, if you have 1, 2, 3, 4, 5, 6, decisions to take. Sometimes maybe one is the most critical decision, yes, but maybe the decision number 5 would need the most quicker one that you need to take. So that optimization is important, but all these things are limited by the time. So natural progression of data projects. Now what do we see? Where do we, at this instance, where are we? I can't show it. So now what do you see? If you take an Excel sheet or a CSV and put it into Claude, you get a presentation out, right? And if you put your prompts, your high-level prompts, optimize the prompts, that's a different scenario. But when you put something, you can get an automated response. That's where we are right now. The robo that you see in front, that's where we are. But the problem is, now that it's a philosophical problem, you can put things and get automated output, but you cannot divide your human interaction totally from that, because that makes the process entirely inhuman. We don't know what the machine is going to give us, but overall the idea of any data project is getting there, the robo case. So you can lay off like 50% salary, you are done. So throughout like 5 year, 6 year time, you like the company is training the data or using you to develop all the pipelines, the automation workflows and everything. Once the company is happy that everything is running, then lay off. Right? That's what we are experiencing, that the robo part is there, people are laid off, but the problem is, like my view is, it's going to crash, because the very people who are keeping this system are needed for its survival, but when you lay them off, certainly there would be a time that this is going to crash. So anyway, the idea of any data project is this: you try to automate the thing. So think about it, like if you are looking at eBay or Daraz or any type of e-commerce platform, think about this automation. Like you order something, and the order is sent to the dealer, the person who is developing or manufacturing, and everything is sorted out. The transaction happens, the bank interaction, everything happens, right? Within 2-3 seconds, the delivery date and your address is also sent, and everything, even you can see the process, the entire process from purchasing all the way to the delivery. So that's the automation that we look for. That's the natural progression of the data projects. Now this, I told you, like this was 2024, 2 years ago, but now we are rapidly evolving towards that automation. So we have the raw data, refined data, and then the production level data. And the raw data is like, in the stage of raw data processing, we have ingestion of data, we put data in, and then data discovery and metadata creation. We'll talk about what is metadata. You have heard of metadata by now. What is metadata? If you go to your mobile phone and go to settings, there's a part called about phone, right? There's something called about phone or something at the bottom. So that is metadata, where it was prepared, manufactured, what is the type of OS, all these things. That's data about data. That's metadata. So metadata should be created, data discovery is there, and then the ingestion, that's the raw stage. Then we go to the refined stage, where we create canonical data for widespread consumption, conduct analysis, modeling and forecasting. So that's mostly the in-house data refined stage, and then the production. We create production quality data, regular reporting and automated data products like your bank statement. So in the bank statement, the bank is going to get a lot of data, and they separate it based on the profile, then they analyze for the bank, for the central bank maybe, for their use, for the managers, and then for the customers. There are different stakeholders, right, in this entire data pipeline. So that's the production level. So progression, data source, we go to exploratory analysis, and then the value creation. That value is not the value of the data, like the numbers in it, the value that we have, like indirect, direct, short-term, long-term value from a data project. Right, ingestion case, in the case of ingestion, I think you learn data mining, right? Have you done lectures in data mining so far? No, it's coming in the next semester, okay. So you'll learn about this, so I'll just go through it very quickly. In the case of ingestion, there is a schema on read, schema on write, so how we get the data and how you write the data. Don't worry, these are not for exams or anything, it's just to understand what is the process of data and why do we need data visualization in this process. So we have, you take the data in and then you output the data. So when you output the data, the information metadata creation has a structure, granularity, accuracy, temporality and scope, right? So when you go to buy something, let's say, how many of you have played cricket, like leather ball cricket? So, right. So when you go to buy something like a leather bat or something, you know the weight of the bat, you know the grip, you know the manufacturer, whether it is like Granicals or KG or whatever. So also you look for the other branding options as well, right? So you have all those options, and even when it is coming for softball cricket as well, you go and find out the best, you know, with the bouncy and all the other features. That's about it. That you know, you have an idea about what you need. So here also we have a scope about temporality and accuracy. So the structure of the data is important, because when you develop a data project, if you don't know about the structure that you want, you may be storing data unnecessarily, because there can be like the organization will fail. If it is too convoluted, it will be difficult to retrieve information from that data. So the structure is important, the structure of the data, like the format and the encoding of the data sets, records and fields. Some question to assess: do all records in the dataset contain the same fields? Sometimes in the unstructured data, like if you are taking like Facebook for example, for each post there would be varying number of comments, varying number of reactions. So it's varying, the fields are varying. So in that case, how do we organize it? So data records in the dataset contain the same fields. How can you access the same fields across records? By position, by name. Think about an Excel sheet. So you can access an Excel sheet in different ways. You can filter it out, right? You can search the name. If you know the record ID or the date range, you can access the date range. So that's how you do it. How are the records delimited, separated in the data set? Do you need sophisticated parsing logic? Separate the records from one another. So now you might have seen APIs. Have you called API records in your previous lectures, like in database? You done database, right? You have done API, application programming interface. So when you get data, sometimes there are a lot of characters, like commas and semicolons and all the other whatnots that separate data. So we need to identify, are there such delimiters? Then how are the record fields delimited from one another? Do you need to parse them? How are record fields encoded? Human readable strings, binary numbers. So when you watch these sci-fi movies, you see like small kids getting these powers and see this 1010 kind of things. Like those are whether this human encoded or only read by computers. Then the granularity, the level of the information, the we can say resolution of the data, the level of encoding that we have, the kinds of entities that each data record represents. So now think about a banking transaction record. So if you are the bank, in any given second, there is a number of transactions happening in the bank. Even today, at this instance also, there is a certain number of transactions happening, right? So that is the level of detail that we need to know in order to come up with some decisions. Now if you think about anybody who is working in LSCG here, MIT or LSCG, right? So as of like 2 years ago, I had a discussion with a colleague. These are like numbers we discussed. I don't know the actual details, but the thing is, according to them, in a given minute, there are like 5 million transactions London Stock Exchange. So think about the transaction volume times the value of those transactions. Like even if it is £1, 5 million pounds being transacted, like they are the transactions. So think about that. In that case, even in that one, you have to go to millisecond level accuracy because the value of transaction is very high. That is the problem. Like if when you are dealing with that kind of an accuracy, you have to go into that level when you are recording data. So data set comprising a set of single sales transaction by individual customers. If you are looking at individual level, fine granularity, a data set where each record represents the total sales. So that's a coarse granularity. In statistics, we can say numerical summaries or records. So if you have done numerical summaries, right? 5-number summary, mean, median, those things like interquartile range, the IQR. So if you are going for that numerical summary, then that's a coarse representation. It's an average of things. But if you are going into the record itself, that's fine granularity. You take all records, like each record one by one. So are the records homogeneous or heterogeneous? Homogeneous represent the same kind of things, or heterogeneous, you have multiple types. And then alternative interpretations of the recordings. So accuracy. So I put the figures to sort of have that idea. The accuracy, like you can have precision and accuracy. What is the difference between precision and accuracy? There are two words, right? Precision and accuracy. What is the difference between these two? What is it? So in the case of precision, you can do the same thing repeatedly. It doesn't need to be accurate. In the case of accuracy, it has to be the thing that you really want, the pinpointing thing. So accuracy is what we need. So in terms of accuracy of data set refers to its quality. In other words, the values populated in record fields in the data set should be consistent and accurate. So there is another word, like rhetorically, accuracy is accurate. So accurate means actually you have some standard in the real world, so you try to match that. So that's being accurate. So if you are, like, for example, if you are developing a house like this, so, or a hall like this, so this is a column, right? This column should be vertical. So being vertical is the accuracy. So you can make it like that. Precision is making all the columns in one direction. So that's precision. You can always be like that, but accuracy is making it vertical. So that we need it to be vertical. Likewise. So for addresses, are the addresses components consistent? So this is very common in Sri Lanka, for example, because in Sri Lanka we don't have a proper addressing system. Like there is no land lot, the codes, those are different. Think about it, like 220 is there, 220A is there, 220B is there. The same house, the front part belongs to one division, the other part belongs to a different one. So if you have renovations or something, you have to get the permission from a different Gram Niladhari or someplace. So a lot of issues are there. This is what accuracy represents. So then temporality, the time of the data. This is very important when you are having data over the samsara. So you have the starting point, and then you have all the details. Like even in Buddhist literature, you have this the Lord Buddha was having the memory or in the entire process of Sara, Sankhya, Kalpa, Lakshya. So that's throughout all those things you acquire the experience, and that is what makes you aware of the human nature, right? The nature of the life itself. So temporality is important. The entity at a particular time, when you hear about what Lord Buddha said in some people, this person was a cat in this life. So this the temporality of things. So you need to know a particular time or set of times what has happened. Right? Then you have accordingly, even though a data set might have been accurate and consistent at the time it was created, subsequent changes might render the representation inaccurate. this is where the fraud detection can come in. So you have a data set, and somehow along the line it was altered. So think about it, like the easiest example is banks. So in a bank, if you pay using your credit cards to a certain facility, let's say it's you go to a fuel pump, right? So you ask the person to have it full tank. So that's an amount. Like then the price may be like 10,237.3. That's the amount. But let's say there are millions of transactions like that, and somehow some guy managed to get those 0.3, like those 0.3, the cents, 3 cents or 30 cents, and then manipulate it in a million transactions, like you get a certain extra amount, right? So that's manipulation. So you can do that, but temporality allows us to look at that because you can go in and out in that. So a customer might have returned the purchase item, although your current records show that the item was sold. But temporality is important because you know when it was sold and when it was returned. So all these things are important in data projects. When was the data set collected? Where are all the records and record fields collected? So these things that we discuss are outputting insights and information derived from the data in the case of metadata creation, because data about data is important. Like if you are taking a mobile phone, the about device is important because you know the OS it has been running, and model and all these things, so that you know what you have. So here also we are talking about that, right? The scope, obviously the scope of a dataset has two major dimensions. The first dimension concerns the number of distinct attributes, and the second dimension concerns the attribute by attribute population coverage. So a lot of people forget about this metadata creation in their research. So I'm sure you are going to do analytics practicum. You have to, otherwise you can't graduate. So you do that. When you do that, you go for the data collection and you forget about this metadata. So people like the examiners ask the question, when did the data was collected? When did you collect the data? Right? What type of granularity does it represent? Right? And also, what is the scope of your data? Right? If you are like, let's say, a simple example that you go to collect data about poverty. Right? In the case of poverty, you have to have a certain economic dimension to that. And how did you collect the data? Because you can't just go and ask everybody about poverty data. You have to go to a certain economic class, right? So that becomes your scope. So you have to have that idea. So whenever you have a data collection process, think about this thing, even though it is related to data wrangling. Right, refine stage. So we were in the earlier, the raw stage, where we get the data, so we are preparing the metadata. Now we are in the refine stage. So designing refined data, addressing the issues in structural, granularity, accuracy and scope. So we can address this refined data to have these problems that you have in the structures, granularities and accuracy refined. So creating optimized data. Optimizing data is not unlike designing refined data. You can think of optimized data as the ideal form of your data. It is designed to simplify any additional downstream work to use the data. Unlike refined data, intended use of optimized data should be highly specified. So names, if you ask your employees, even if your customers are there, if you ask them to put their name and address, most of them, maybe some of them, type only in caps. You like type caps. Some people write the entire name in simple letters. And some people, you specifically ask surname, let's say the name and the surname, they will write surname and the name, right? Because there are a lot of things involved in data collection. And then if you say name with initials, right? Some people write initial first and the name. Some people write name first and the initials. So you can find a lot of such variations when you are even collecting data. So optimization means you make it optimized. Right. So basic steps of data wrangling: access, transform or profile, and publish. So you can see there's a loop: access and the transform on profile. So now I take your memory back to what we discussed in Power BI. In Power BI, you have a data query, right? You go to transform data and you go to a certain set of queries, certain transformation. So that is where you do the data wrangling in Power BI. So we access, do that repeatedly, and then go for publishing. So core types of transformation: structuring, enriching, cleansing. Structuring primarily involves moving record fields, like changing things. Then enriching, transformation at fundamentally new values. So if you have missing values, you add them. And also if you need, like for example, you have distance and time, you add new value of velocity, the distance divided by time. So that's a new thing, enriching data. So if someone is interested in the fastest vehicle, for example, then you can select the velocity column. Cleansing, cleanse the data set. Fixing quality and consistency, like null values, the missing value part. Right. Then profiling, individual field value profiling, set based profiling. So we will come to this in few minutes, like when we talk about R for data wrangling, how we talk about the separation of fields and how we talk about separation of attributes. There are different individual and set based. So the idea of now, you have heard of sets, right? You have done in statistics, I'm sure you did some probability class, right? So you talk about sets. Okay. So if I may draw it here, so in a set, let's say you have a set. Let me name this set as students or participants of MBA. So this is the set that we are talking about. Now tell me, inside this set, a mutually exclusive division, subsets, mutually exclusive subsets inside this. Excellent. So biological male and female, nowadays it's very difficult to talk about this problem. So there is male and female biological definition. So that's mutually exclusive. That's mutually exclusive. You can put a NOT gate. Now you can easily put them into two separate pegs. Then you can have like blurred areas as well, like maybe students coming from the same university, undergraduate degree from the same university. But again, we are talking about master batch. So they are also same university but different batches. So some may be senior from a same university, a senior batch, same university, junior batch. So there is another separation there, but in terms of one particular logic, they belong to the same university. So likewise, that's what we call individual field value profiling and set-based profiling. So in the case of set-based profiling, focus on the shape and the extent of the distribution of values found within a single record field or the range of relationships between multiple record fields. So English word may be like bit, I don't know, like you need to find the meaning out of it, but the real meaning is here, how we take the records out from the data. Right. So role of the analyst. Right. I always like the philosophy, so it's like the role of being human. Like we all play our roles, right? As a son, as a father, as a daughter, as a sister, brother. So we have different roles in our lives, right? So the role of analyst also, there's a part of the analyst that talks about the ingestion of data, describing, accessing the data, then the design and refine data, optimizing the data. So the line between an analyst and a data scientist can be blurry. Analysts will pursue deeper analysis like dharma and karma, For example, in addition to identifying correlative indicators of KPI trends, they might perform causal analysis on these indicators to better understand the dynamics. So it's very tricky. Now you are professionals coming from different backgrounds. You have a certain basic understanding or a basic degree that defines you as experts. Now we are working in the industry as analysts. So you have that core principle, like being someone, being an expert, and you bring that dimension to the data. That's what you are as an analyst. So by becoming a business analyst, or business analyst for namesake, but as an analyst, what you bring in is that the dimension, the expertise that you have. So for you, I would say this is additional to the lecture, like having that expertise is very important. Like being an expert is important, because the data wrangling part, the other things are easy now. With all those ChatGPT or Claude or whatever AI tools and everything, that thing is easier now. But being an expert is the difficult part, right? So I always tell this to the students as well, the undergraduates as well, like become someone who can call yourself, there's a core in it, like there's a core, someone who understands something. Like if you go to these small shops, right, when you are traveling or when you are abroad, you go to maybe a bakery, like there are people who do their like puddings and bakery items. It's like a small shop. If you go to them and ask, maybe the recipe comes from their grandmothers, or something, like there is a recipe that they have developed. That's the only thing that they have done. It's the same cake, but there's a different flavor to it. So that's that expertise that makes you who you are. And the other part, obviously, you have to develop from other skills like this. So analyst has to have a deeper understanding of what they are dealing with. That's basically what it is. So it's like back in the days when we learned about calculators, for example, calculator was given to everybody. Can be an engineer, quantity surveyor, an accountant, all use calculators. Nowadays, it's the same thing. Data science is given to everybody. There are data scientists who build the science of data science, right? How to analyze it differently, write a code to optimize it, like how to get data from IoT sensors and all these, technical details of data science. But data science is like the calculator. You never want to learn how a calculator works, right? There's a circuit, there's a battery, you put the battery and then you work, because calculation is what you want, right? So that is what you want. Being an analyst means analysis is what you want. You need to know how the process works, like how the data is taken, optimize the reason of it, and then give your deeper analysis. Because this is where I feel a lot of people get tangled, because say you are hired as an agricultural analyst, right? Then the first thing that the company wants is, okay, you are good with analysis, and tell us how to put this seed. Is it a good time to harvest? Right? Is it a good time to plant these things? But if you don't know agriculture, then how can you make sure that all the details that you read in the internet, the ChatGPT is giving like a lengthy description about why you need to. If you ask the same prompt in a different way, why you should not plant, it will give you the same like a different prompt saying it's very bad to plant this thing. So your expertise is important. So that's the important thing that you should bring up. Okay, so that's about data wrangling dynamics. Data wrangling using R. We talked about the dynamics of data wrangling. We, like having a helicopter view of what the entire process is. So you know how to collect data and what is it in metadata, right? So the background, this background is what I'm going to talk about, and I'll talk about grammar for data wrangling in detail in a different lecture. I have given you the lectures. I'll start it after I talk about the background. So what is knowledge discovery? So what do you mean by understanding something. So the learning outcome, name the process of knowledge discovery, describe the data preparation workflow, identify the applicability of R software for data wrangling. Right. So this is where the things get really, really interesting. So in the case of knowledge discovery, can you focus on this figure? Right. Figure is important. The figure to the right. So what do you see there? Let's.
So in the top point, it's only same.
Is it different?
Oh.
Okay. I'll put this available. So just focus on the screen now. I will make it. The link maybe I copied the same thing and pasted. So I'll make it available. Don't worry. But focus on the figure now. So what do you see on the figure? What do you see? Forget about the text. Focus on the figure. What do you see on the figure? As kids, have you played this jigsaw puzzle thing? Jigsaw puzzles? Right. So you see the pieces. Right? You see the pieces and they are all scrambled and it's there. So what we do is, we have a particular problem specification and then understanding of the problem, then data pre-processing, data mining, evaluation, result. Then you get a picture out of it. So in reality also, the values and other details are scattered and jumbled like this. Right? So if you think about your own expenses, your own life, think about it. All these things are there, they are scattered. You may have a lot of bills from Uber, you may have a lot of bills from coffee shops, right? Internet, every now and then those happy buying things, right? You buy things just to make yourself happy. You don't know, the expenses are scattered everywhere. In the bills, in your bank statements, if you are using credit cards and here and there. But if you compile them, you will get the big picture. What is your most preferred expense? Right? What is the frequency that you visit this place? Sometimes it's overly predictable that you go on Sunday to this place. On Friday you will be found in this place with this person. So it's very predictable. So knowledge discovery is a philosophical thing where you develop an understanding about a phenomena or something that you want, a scenario, and you can write it down or have a definite equation or a picture of what is going to happen. If you think about the knowledge about a recipe, so you know how to, now the sugar, tea bags and the hot water, they are in separate places. But when you combine them, you make a tea. Right? So knowledge about making tea is there. So once you know how to do it, you can write it down on a board, or you can write or have something fixed. This is the way to do it. So that is knowledge discovery. So when you are dealing with data, it is something of intangible nature. You can't touch it. It's not physical, but it's there. The concept is there. So in order to, the first thing to understand something or to develop knowledge is to understand the problem specification. So identifying and organizing the application domain, the relevant prior knowledge experts have, and the end final user's goal. So I told you agriculture analyst case. So if you are hired an agriculture analyst, that person needs to know about agriculture first and then become an analyst. Right? So you have to have an idea. That's the most important thing when you define the problem specification. The problem. It's very sensitive. So now I do a lot of research. So one of the key, I have to say, some impactful thing that we do is try to analyze this human-elephant conflict. Human-elephant conflict, what we call HEC. You know, in northern parts of Sri Lanka and southern parts of Sri Lanka, you have elephants like roaming around, and they are called wild elephants. Like apparently, elephants in the temples are not wild, so they are they are temple elephants, but there are wild elephants, like peasants working around the country. So they cause problems, and they cause problems, but they don't do problems, right? The humans are the best and elephants are the worst. So we try to analyze this. When we go to now, we can write thousands of problem statements here in monotone, right? We can write it down, like number of elephants, the density of elephants, we have to do this, we have to do that, and we go to the field, then only we realize how they behave. What is the problem actually on the field? So in order to write that problem specification, we have to have an idea about the problem from the people who are experiencing the problem, right? So I'm not saying that every now and then you have to go and ask everybody, but this problem specification is important because you need to know what you really want to solve. If you don't know what you want to solve, then we call it depression. Right? So you should not go into depression. So if your problem has a problem, you come back and define a new problem. That's how that is why you have a cyclic process. You define a problem. If that problem has a problem, you come back and define a new problem so that you can solve the problem. So understanding the problem is the second thing. So the process goes like that, cyclic, because you don't have a clear picture. Because when you are trying to solve a jigsaw puzzle, you know the final figure, yes, you have to have an idea about the outline, like what is this. And so when I was solving jigsaw puzzles, the first thing that I took notice was that edges, right? The edges has to be like corners, right? You can't have the jigsaw lines there. So you can start with the edges. You can put them on the frame. If you know where these frames are, then half of the puzzle, I mean not half, but you know where to start. Okay, right. Now let's go to the preparation, the processing part. Cleans and combines. That's what we talked about in the data wrangling case. Then the data mining, which you will learn in the next semester, where we the DM means not direct message. It's data mining. So chooses the best DM task, whether to classify regression, clustering, or association. Like what do we really need to cluster the information that we need. Finally, tuning parameters and validating the DM algorithm to solve the problem. Evaluation, estimating and interpreting the mind patterns based on investigations that you need, and then exploration of the results. So the data preparation part is here, right? I'm not going to talk about data mining because you will learn about it, but this is where I want to focus. So data reduction. In Power BI, we call this data slicing and dicing. Slicing and dicing. Slicing means like you cut like that. Dicing means cut like that. So slicing and dicing means you have selection and filtering. These words are important. Selection and filtering. They have two different meanings. Selection means you have a set of columns, records, right? If you take your result sheet, for example, you have your, like the entire class result sheet, you have your names like that, and you have your subject, each semester subject in a column. So if you want to take a particular semester's result out, then what you need to do is select the columns. So that's selection, right? Then filtering, or the instant selection, here it's called instant selection, but we call it filtering. So in the case of filtering, what we do is, you are familiar with Excel filtering, right? So you have a filtering, you select particular entire record of that filtering. So it can be a name, it can be an index number, a value greater than certain value. So that's filtering. Then you have the discretization, which is you convert the values into digital forms. We will not, I don't talk about it here. Maybe like when you talk about like, for example, let's say you have your mobile phone locations. So your mobile phone locations, each one of you will have a point location, right? In order to find the density, we take the point and discretize it so that for a given area, how many people were there. So that's the idea of that. Anyway, the idea here, the important thing is selection and filtering. Right? Feature selection, instance selection. So in the case of feature selection, basically selecting the columns. Instance selection, basically selecting the records. So if we combine them, what do we have? If we combine the column selection or the selection and the filtering, what do we have? What do we have? We have a subset. We have a selection of certain attributes, selection of certain records. So we have a subset like here. Male and female, mutually exclusive, yes. But if we want to find out a certain set of people who are coming from a certain university, who belong to a certain batch, then we are talking about a subset. So that's creating a subset, right? Discretization need, feature extraction and instance generation. How do I reduce the dimensionality of data, remove redundant, conflictive examples, simplify the domain of an attribute, and fill in gaps in data. So feature selection, instance selection, discretization, feature extraction. So that is the only thing that I want from this lecture, because I'll be talking about tidyverse. So we have 3 lectures. In these 3 lectures, I'm going to talk about the data wrangling part, and also I'll be details of R. So I'll go through it. So first, learning objectives: import, inspect, and explore tabular data sets using readr and dplyr. I talked about the dplyr package last time. Also the readr package is about reading Excel and CSV files. Then you have manipulating data with dplyr, select, filter, mutate, and arrange. So select and filter we talked about early on. Selection is column selection, filtering is filtering out the records, and mutate means creating new columns. And arrange, obviously the name arrange is easy to understand. Reshaping data between wide and long format. So wide and long format, as the word say, wide and the long. Long is longer version, wide is wide. Then merge and join multiple data sets by common keys. So primary key, we talked about this in the Power BI. Visualize data using ggplot2, scatter plots, bar plots, heat maps. We talked about it, so I'm not going into detail of that. Applying advanced operations, lag variables, moving average, window functions. Some of them I think I have removed, but we'll talk about some of the advanced operations. So we'll talk about required R packages. We need readr and dplyr. Readr, as the word says, handles the CSV files, comma separated files, outputs, and dplyr provides a core grammar of graphics. So we talked about graphic as a language, so grammar of graphics. We'll talk about the filter, selection, and other things. Tidyr provides the gather function and the spread function for reshaping data. So the words are easy to understand here, right? Tidy means what? Tidy means like organizing things, making it tidy. So wide and long formats, tidyr. Wide and long formats, pivoting the data, unpivoting. I don't know whether the mosquitoes. ggplot2 is for the grammar of graphics. So GG means grammar of graphics. And then lubridate means it's for the dates, the date variables, time. Lubridate is for the time filtering. We'll start with the environment setup. So if you have R, I'll do it this way. I'll give you like 1 to 2 minutes to do your work as I talk about it here. So first thing, you have to install the packages dplyr, tidyr, ggplot2, and readr. the first part, install required packages. Skip any already installed. So if you have them installed in your machine, no problem. But otherwise, type them. Install packages, right? Copy paste this, and then run it. First part, install packages part. Run it in your computer. Make sure you have an internet package or internet activated internet connection. So run it. Install dot packages. So easier thing is you just type in install, it will automatically come install.packages, and then type dplYR, copy that, and then tidyr ggplot2 readr. That's all. You don't need to worry much. It's very easy to do it. So kindly, when you have done it, just raise your hand so I know the number of people who have done it, so I can move quickly. Right, so I am sure you have done this now. Install.packages, it will install dplYR, tidyr, ggplot2 and readr. So these are the packages we need. Then go to library dplYR, so it will load the libraries. Let's go to the next one. So right. Okay. Now, where are you working? Where is your RStudio? When you load it, from where does it load? We talked about a code last time. What is that code to check the directory where you are working? What is the code to check the directory where you are working? Your working directory. How do we get it? How do we get the working directory? Get WD. So type in your console get WD and check where you are working right now. Get WD. Get WD brackets. It will give you where you are working. Okay. So then you have to set your working directory. How do we do that? Set working directory, set WD, and inside the brackets type the string of your folder, where your folder path is. So that folder path should be the place where you have your orders.csv, customers.csv and those files, where you have your extracted folder is the best place. There you have all the files. So set your working directory to that. Set your working directory to that path. Should not get a lot of time. So once you do that, you can run this code. You read the CSV orders.csv and make it orders dataset. Run that. So when you read it, you can see some of the things that we discussed in previous lecture slide. You have the delimiter, then the character type, order date, shipping mode, those are characters, char. Then you have double, where you have the numerical values, number, sales, quantity, discount, profit, whereas number is the order ID actually. So we have to rename it, we will do that. Now, I hope you have imported the data. Yes? Done? Okay. Is that a mosquito? So, we'll first of all look at the orders table, orders data table, inspect the column names and data types. You can do this by str orders, and you get the number of columns that you have, their data type, right? The specifications of the table. You can get this. Right. So str orders gives you the column names and the data types. Right. Let's go forward. Summary, as the word suggests. Now str just gives you the details of your columns, and the summary orders, that gives you the numerical summaries of your 5 number summaries of your columns. So you have for example, now number, is it correct? Here number means that order ID. It's not a number. It's just a text value, but here since we haven't changed it so far, it has been taken as a number. Because it's a number, we have to actually do it as a factor separately, but in this lecture I haven't done it, but it's there. Then you have the order date. It is also not identified as a date variable. Then you have shipping date, sales, quantity, discount. All the numerical columns have got their 5 number summary. All the numerical columns have their 5 number summary. Minimum, maximum, first quarter, median, mean, third quartile. The values are there. So that's the summary of your order state. Summary. Okay. This is just one line of code, so I'll go forward. Then glimpse. What does English word glimpse say? Glimpse. Glimpse, just a glimpse of something. So we have the data set, it's an overview. Compare with the str output, it's the same kind of, but it's more compact. It's giving us some idea about what is in the data set. Glimpse. Okay. So there are 3 exercises. You can do them, but we'll go through the lecture. So you can also do it. Install the Lubridate package. So how do we install Lubridate? Install.packages Lubridate. It will get installed. Then explore the first few rows using head. You can type in head, and you can note that data type of each column. Then use glimpse for a quick overview, compare it output to the str. We have done it. So it's the same exercise that we did. We'll start with slicing, or the selection of columns. we will start with renaming a single column. Can you, before you go into this code, can you type in rename? Just type in rename on the console. Just type in rename, and what do you get when you type in rename? In front of that, you have within brackets which package it is from. When you type in rename, from which package does it emerge? DPLYR, right? Or tidyr? From where? It should be DPLYR. So, because it is from DPLYR, we can use the pipe command. So, the pipe command, Control-Shift-M. Control-Shift-M will give you that icon, the percentage greater than percentage. That's the pipe command. So, what do we do here? If you just type in rename, rename will have data, comma, something, something. Instead of doing all these things, we use the pipe command. We take the data set, use the pipe command, and then push that into rename. So that's what we do. Orders, then rename the order ID to like number is the original one that we have. Instead, put order ID. So the naming one comes first, the new name comes first, the old name comes second. So order ID equals number. Rename the column. Orders, rename, order ID is the number. So number column will be renamed. Now when you run it, you would see the new orders table, new in the sense the same thing, but renamed with order ID. Okay, now you have your presentation. Can you run the second code and tell me whether you get an error? Okay, what is the error? Object something, is it? Can you see what is the error? When you read the code, what is the error? Custom ID is there. Look at the orders table and see there is an issue with the column name. So custom ID has a space in it. So you can write it as is and put it inside brackets. So custom ID, give it a space, the real name custom ID with a space, ID space. So put that inside quotation marks, then it will work. Same code, but the name is not there. Custom ID is customer space ID. Does it work? I will also do the coding, otherwise you will find errors. So we'll first of all we need to get the read CSV, so I'll take this one. So you have the same thing. Then I'll go to this code. So the error is can't select columns that don't exist because customer ID is not there. So if you look at the orders table, customer ID has a spacing. So we need to incorporate that spacing. So we will do that by changing customer ID here, put that inside the quotations and then enter. Order date doesn't exist. I think order date also has a space. Order date here also doesn't have a space. Now it is there. Okay, let's go forward. I will go back to the presentation and you need to also type in. All right. Right. So order date and customer ID, they have a spacing in the data, so you have the data space. Okay, now so selected orders will have something like this, right? So I'll show you something else as well. Now in the code selected, let me go to the code. So in our code, what do we have? Selected orders is the orders pipe, order ID, and then the customer ID, order date, all these things are there. Now the selected orders, when you do the coding, will have these columns. Now imagine that we don't want, for example, customer ID or let's say order ID, whatever. We don't need this in our data set. So we need to remove it, just one column. In order to remove just one column, we don't need to write in all those things and include other columns. We can go for set notation, like we can easily say selected orders. I just take selected orders, put selected orders here, and I don't need customer ID. Hence what I do is I'll say minus customer ID. And then see what will happen to my selected orders. Now customer ID is not there. So if it is just one column or two columns or whatever, the smaller number of columns that you don't want, you can use negative sign in front of it. So they will be removed from your data set. So I'll instead of going into the presentation, I will go like this, it's easier. Now let's go to the next slide. Select focuses on name columns, filter subsets rows by a logical condition. So previous lecture slide we talked about slicing and dicing. So selection will select the column values, columns, whereas in the case of filtering, it's filtering out the record. So we can use the same here, and it's easier because in dplyr we can easily use the pipe command. So I'm going to use filter command here. So the selection already done. Filter command here, high sales orders are taken as order. So let's go to this in R. So what I'm going to do is read the code. High sales orders are from orders, we use the pipe command, filter sales greater than 1000. whatever value that is inside sales that is greater than 1000 will be filtered out. That is what happens. So if you want to say, for example, this is high sales orders. If we want to, this is high sales orders, everything is greater than 1000 sales. If we want to have like low sales orders, what can we do? If you want low sales orders, what do we do? Simply change the sign here. Greater than becomes less than. So if we want low sales orders, sales less than 1000. Then you have the low sales order. That's very simple. So you have sales always less than 1000. Okay, right. Let's go to the next slide. Mutate. So have you watched Teenage Mutant Ninja Turtles cartoon? So mutation means new things. X-Men also is about mutation. So mutate is giving new columns. So how do we give new columns? We are doing feature engineering. Like the fancy word is feature engineering. We can do new features out of the existing features. So orders, the pipe command is very useful here, because pipe commands allows you to easily see the codes. Right? So we'll go ahead with the coding again. So in this code, orders is the data set that we have. We take orders and use pipe command to put it in to the mutate, and inside mutate we don't need to do anything. We just type in whatever the column that we need. We need profit margin column, which is profit divided by sales. Profit column is there, sales column is there. We are using those two columns, divide them, multiply by 100 to get the percentage. So we just put the new column, profit margin, inside the orders. Right? When we run it, our orders table will have a profit margin column. Right? So that's what mutation or mutate means. Mutate. All these words are very easy to understand and remember. Select, filter, mutate, those are very simple. Glimpse, right? Let's go to our next code. Now, when you are doing machine learning, you may need to classify or pre-process data for training, for example. So classifying each order into sales tier using case when. So case when is also easy to understand. It's an English word, case when. When this happens, case when. So we use orders, a pipe command again, mutate, add a new column, sales category, that's the new column. Case when this happens, sales greater than 1000, put it as high, sales greater than 500, put it as medium, and if it is not true, then it is low. So either in other cases it becomes false, false becomes true, so true becomes low. You get it? The hierarchy of the logic. If we put 500 at the top, what will happen? All the values greater than 500 will become high, and then the next logic will not go into the next logic. So it goes case, first thing is true, apply. Second thing, if it is not true, go to the second one. If it is not true, then the third one. That's how it goes. So let's run this. Orders done. So when you go to the orders table now, orders table here, you can see sales category very nicely, low, medium, right. Okay, so the next slide is the exercise. Select all columns from orders except customer ID and order date. I have shown you how to do it. It's very simple. Put a negative sign in front of it. filter orders where profit is negative and sales is greater than 500, you put an AND logic or case when can do that. Create a new column that classifies orders as high, medium, low. We have done that. Okay, let's go to the next one. Reshaping. So in which package we do have reshaping? In which package? Which package? TidyR. So tidy means organizing. So TidyR, we have long and wide operations. So we will just run these codes. It will be straightforward. Long orders will look like long. So let's go to long orders, enter, right. Could not find function gather. Why do I get this error? When you run it, do you get this error? Have you run this code? Do you get the error? No. Those who are not getting the error, can you raise your hands, please? When you run this command, do you get an error or no? No. Right. Those who are not getting an error, can you raise your hands, please? Okay. Why do I get an error? Can you read the error? What does it say? Cannot find the function gather. Why? Gather is in TidyR. I didn't load TidyR. I started loading only dplyr when I started. So I need to load it. Load TidyR. Maybe I have to install it. And now I can load it. I have to close and I have to close and reopen this. So that's why you need to have a, before I close, I will copy all the codes. Right. I will use a script now. I will use a script, R script, and I will always set my working directory at the top. So where I am working, it's easier for me to see it. So I'm going to run this, Control Enter, set working directory, and my next task is bringing in the values. So I will quickly read the data. So I will go back, reading the data. I'll also load them, loading the libraries. Select, Control Enter. ggplot is there, readr is there, dplyr is there, tidyr, all the packages are there. So now it should work. So the next one is I will read my data set. And it's there in the package. Control Enter, done. And now I am going to do the operations here. orders, I'm sure I'll get an error, but anyway, let's see. Let's see whether I can run the long orders code. Okay, it works. So long orders, let's see what do we get. So what do we have when we type in long orders? What do we have? Metric and value. Metric is the name of the value. So the code is key is the metric, value is the value, and metric comes from sales and other one comes from profit. What does it mean? We are simply unraveling the data set. So in the original orders table, look at the original orders table. In the case of orders table, now I haven't added all those features that you have, but look at the orders table. In the orders table, you have sales and profit like this. In the long orders table, in the case of long orders table, you have something called metric, right? This is the orders table. This is the long orders table. Orders table, long orders table. So I have unraveled it. I have taken the sales as a metric, added a new thing as metric, right? Then look at the wide table. Let's look at wide. Let's see. I'm sure we are going to get an error here. Yeah. What does this error mean? Yeah, there's an error. So when you run the next command, do you get an error? Like this. What does it mean? What does it mean? You get an error, right? What does it mean? Read the error. Each row of output must be identified by a unique combination of keys. Keys are shared for 64 rows. So what does it mean? It means that there are repeated order IDs. There are no unique combinations. There are repeated things. So because of that, you can't spread it out. So we need to make sure that we have we have to make them unique. So let's look at the next code. It will make it. So orders distinct. I'm going to type in this thing. If you type in distinct, that is from dplyr, right? So in the dplyr, there's a distinct package. So I'm going to create orders, distinct orders, and put them into clean orders. We will see the difference. So orders clean, I'm going to put it in, and I have an orders clean, and let's look at the number of rows in orders as well as number of rows in orders clean. So number of rows in orders, n row, 10,009. Number of rows in orders clean is 993. What does it mean? What does it mean? 10,009 minus 999.3. What is the value? 10,009 minus 9,993. What is the value? 16. Okay, 16, right? Keep that in mind. Let's run that previous code. Shared rows, that's 16, actually that's 16 times 4. So basically you have columns, or rather rows that have the same value. That's why you can't have this spread here. So let's with the new data set, which is the clean order, rather than having the, let's go to the wide orders from our clean data set, clean orders data set. I'm going to type in clean orders. Where is the orders clean? Is it? Yeah, it's orders clean. Go to orders clean and do the operation wide orders. I'll just copy paste the same code, it's easier. Now we have to create the long orders from whatever that we have. Right, gather key metric, value, sales, profit. Those are the values, sales and the profit, long orders. And I'm going to use that long order and make it wide orders. Now it should work because all the values are unique. And let's see what is the difference between wide and long orders. Let's look at long orders and then let's look at wide orders. Wide orders and the long orders. So what is the difference? Check and see what is the difference. Okay, let's move quickly. Summary glimpse, no need, we have done that. Sorting also, just sort the things, it's not a big thing. Let's run this. Let's run this entire code. Now just copy this code and put it in your R file. And run it. There should be an error. This part, this thing, run it. There is an error. So the first error, what is the first error? Order date not found. So because the order date has a spacing, that's the problem. So I will put that and order date. Let's run this part. It works. Because order date, the name order date doesn't exist as a combination, you have a space. Order space date. Fix that part. Giving erroneous codes is fun, right? You can't run it. Otherwise, you just type in and then you run. So, you have to have a spacing between order and date. The name is order space date. Right. Then let's run the second one, sorted orders. Orders, pipe command, arrange order date, descending, profit. That's what it says. Profit is in the descending order. What is the difference between ascending order and descending order? Ascending means you are starting from the bottom to the up. Descending means you start from the top to the bottom. So let's go to the sorted orders, the next command, next code. Now we get another error because order date again has a spacing. Right. Now we have sorted orders. You can check them, descending order, profit is descending. Right. The next one. Now this is the importance of being in your working directory, because in your working directory you have the customers.csv file. You have all the files. So we can easily call them. Customers is from the customers.csv and we have taken it. And then there's another new code. We are going to merge it. Merging the data. Merge the data. Merge orders and the customers. So in order to merge, we need to have two things, orders table and the customers table. But how do we merge it? How do we merge it? So how many, I'm sure when you have a phone charger, USB phone charger, maybe USB-C on the other side and the USB and the USB in this side. So when you try to connect it to the charger, there is a USB side, right? You have to turn it accordingly so that you can plug it in. USB 2.0, 3.0, you have a little like a block there, so you have to turn it. So we ask the code to merge, but the code will not simply merge it because we don't know how to merge it. In order to merge, there needs to be connecting space, right? There should be a connecting thing, like male to male or female to female, whatever, female, male, you need to have a certain connector. So that connector is what we have here as by. Do we get an error or not? I am asking this question. Will we get an error or not before running this code? No. Those who are saying we will get an error, can you raise your hands? This is the series how not to code, so it's fun. So do we get an error or not? Right, let's run it. We should get an error. Right. Why do we get an error? Why do we get an error? The error says by must specify a uniquely valid column. What does it mean? I told you the connecting column needs to be clear. We said customer ID, but it's just one name. So it should be in both tables. In both customers table and orders table, there should be a column named customer ID. It is not there. That's the problem. Look at the customers table that we have taken. It is ID, not customer ID. So we need to rename it to match this. So I'm going to, how do we rename it? We renamed it last time in like few minutes ago. How do we rename DPLYR package? Just rename it, right? So if you just type in rename, you can see it's a DPLYR package. So what we are going to do is we are going to rename the customers table. So customers, it is, yeah, customers table, right? How do we rename it? We are going to rename it, and how do we going to rename it? We have to put the customers table first and create the pipe command, Control Shift M. This is Mac, so it should be Shift Command M. In Windows it's Control Shift M. In Mac it is Shift Command M. So customers, pipe in and rename. Rename. How do we rename? New name should come first. New name is customer ID. That should be equal to the existing one, that is simply ID. Now you can see customer ID is there, right? Is it clear or is it difficult to read? I have changed the size. Yeah, at least this is clear. So customers, now it is renamed. Now let's go to that code, merging code. Merge. Yeah, merge here. So we are going to merge this. Merging the data, orders and customers by customer ID. Now it should work. Why it's not working? Because the customer ID has a space. Now it's working. So the unique identifier needs to have the same column name, and if it is not there, you need to rename it. And what does it all equals true mean? All that matches are connected. Right, let's go to our next case. So done. Sort orders. Now I'll leave the exercises to you. Now let's go basic visualization. We talked about basic visualization last time, so I'll be rushing into this. I'll be quick with that. So just copy paste this ggplot2 commands. It should work. I will copy paste that into my R. So there is a little code here. We'll run the scatter plot. Run the scatter plot. It will give you this scatter plot. So if I zoom in, you can see the scatter plot. Nothing fancy. It's just a simple scatter plot. But there is another thing. Merge data. Separate wider. Let's look at the merge data, for example. So this is the same data set. This is the same data set that you had for your Power BI. Remember, in Power BI we did something at the very beginning. What did we do? In Power BI class, what did we do first when we take the data set? Remember, what did we do? We split the data based on town and state. So the delimiter was comma. So we take the data, put it into the transform, and then split the data based on the comma separation. So we are going to do the same here. If you look at the data, it's the same data set, town comma state is there. So our next code, which is after the scatter plot, we are going to separate wider delimiter town comma state. Delimiter is the comma, and then names will be put as town and state. That's what we are going to do next. The merged data becomes a new data set, the same data set, but we are going to split it based on the comma. When you run it and now go to the merged data set, you can see town and state are splitted, right? So this is, I'm just taking you through the same process so that you understand the process, the same thing. The data set is the same. So split the data, and the next command is simply using the merge data to a very beautiful figure. Let's run this and see what do we get. So this is, so in order to do that, what do we need? If we had town comma state like that, we cannot develop this figure, right? So why are we doing this? Why do we learn this? Because what is the difference between an interactive dashboard and a static figure? What is the difference? Static figure, developing a figure like this. You code it, you develop it. When it comes to interactive active dashboards, you are interacting with it, you select different buttons. Based on the buttons, the visualizations change, right? So it's basically a code. It's a code running inside. So whatever that we did here will be applied in the dashboard itself. So the code is the one that is running. You get the visuals, the graphical visuals like this. So here, New York, Los Angeles, Philadelphia, all these things, San Francisco, they came because we split it here early on as town comma state. So we can call them as town, we can call them as state, right? So let's go to the next one. It is very nice. The next visualization, this one. It should be a very pretty image. Let's run this. State, it's not the orders, it has to be coming from the merged data set. Merged, it's coming from merged data, because town comma state is not in the orders data. Let's see, merged data. Right, look at this. So what do we have? Here we have faceted image of different town and country, town by numbers of orders per state. So in a visualization, if you had sliders, this is what you get. Like you select and then you get the visualization like that. You can interact with it. So this has a lot of information. Right. Let's go to the next part, summarizing and counting data. This is what happens in your Power BI when you try to have maybe let's say a measure, let's say something of a numerical summary. So whenever you take this, right, you get this value. That's just summary of the by town. So summary by town, if I open it, summary by town will be town, mean sales, total profit. It's just a code giving you the values, summary of the values, summary of each of these things and the count. Right. Pivoting data. What do you mean by pivoting? Pivoting means what? Pivot on something, what does it mean? Pivot. Pivot, there's a pivoting point, so it's rotating around something. So I'll just quickly go through it. So I'll copy the entire code and run it. So to do this, we need the products CSV. We are taking the product CSV, and then we are using the names of the merged data. I'll go through one by one. So here I'm going to take the product CSV because I am in the working folder. I can easily just name it and I get it. And then names mean whatever the column names that we have. So in the merge data and the product, so product ID is there. Here we have product ID. There's a spacing. So we need to merge it. Now I'm going fast. Left join products by product ID. Left join has all rows merge data. But if we run this, so products, it will say problem with product ID. Y column must be present in the data because product ID is not there in the merge data, right? Products cannot be left joined because product ID is not there, because in the names you can see product ID is only there in the merge data, but in the products table you don't have it. So we need to rename it like we did last time. So I'm going to rename this products. Rename. So the new name is the product ID, right? The older name is the ID. So in the names you have ID, right? Products ID. Right, now when I run it, merging should work because now it knows to left join, you have the same column. So just left join them from the left side. Right, the next one, merging the data, then the pivoting. So let's look at pivot data. Pivot the orders. group by category and subcategory. Merge data, let's say merge data should have something called category. Category is there. What is the problem? Category, subcategory, here. So what is the problem here? Can you identify the problem? What is the problem? What is the problem? Problem is this one. This. The problem is the character. When I copy paste it from PowerPoint, it was the comma, this comma, but actually it should be this comma. It's a character mismatch problem. Now it should work. It should work because when I copy paste from PowerPoint, that comma there was taken as a character. So it tries to identify that character, because of that you get an error. Right? So subcategory was there. Now I can see the pivot orders based on subcategory. I have the pivoted orders. Right, let's go quickly. Merge data missing value problem, lagged variable. You can run them separately, right? In order to run this, if you run this, you will get an error because you have to load Lubridate package. If you haven't loaded it, then you will not be able to see this. Let's see whether I can run it, because there are a lot of issues in these codes. I purposefully made them to be like that, so it's difficult for me to run it. I don't know which one will, even for me it is difficult. So I don't know which one has the problem. So yeah, you need to have argument date. Yeah, first of all you need to get the library Lubridate. And then if you run it, yeah, it works. So if you have to get the Lubridate package to avoid that error. Then you can easily get that, and once you get it, 3 period moving average will be there in the merge data set. You can go and see it's somewhere there. Yeah, ARIMA. Have you done time series analysis? Okay, so there you have the lag, the sales, MA, and the 3 moving average. These are NA because you don't have the 3 values. Right, so that's the first lecture. You have this app.r with you, right? App.r. So you can either double click and open it in R. It's R Shiny dashboard. Don't worry about the codes, okay? Just run this. At the bottom you have this Shiny app. Just select everything and run. App.r, select everything and run. Open app.r in RStudio, select everything and run. What do you get? Do you get this? Does it ask you to install Shiny or something? Then install it. Whatever the package asks, install Shiny. Okay. So while you do that, let me show you some interesting things. Now you can, in fact, so what is the purpose of a dashboard at the end? So as you do that, I'll explain. So anyway, we'll come to that as we go along the lecture. This is in the final part of the lecture, so I just open it so that we can have an interactive discussion. So when you have a dashboard, the purpose of a dashboard is visual analytics. The person who is interacting with the dashboard will select things and get an idea of whatever she or he needs. So this is a dashboard. It has a graphical user interface, what we call UI, user interface, right? And also inside that you have some selections that the user can make. Like if it is about furniture, if it is about office supplies, right? You can do many iterations, you can do many variations. So now this is the thing about R. If you do an analysis in R, it can be machine learning, even deep learning, spatial analysis, whatever statistical analysis. If you do it in R, you can nicely show it as a dashboard at the end. You can create the dashboard and this dashboard will be available. You can even present it in your research or your findings. If you do it in Python, you have to, again, you can do it, you can create a Streamlit or Plotly dashboard and then show it. That's all right. But the thing is, with this, if you have created new features, if you have done any classification, you can easily include all these things and show it as a dashboard. So these are Shiny dashboards. And where do they run? They run here, HTTP 127.0.0.0014128 port means that is where the server is. So it creates its own server. It creates its own server and you can easily interact with it. So that's how Shiny dashboards work. So that's how any dashboard work in practical terms. If you want to develop a Python dashboard, first of all you have to have the backend, the process where the things work, and then you have to have a server, then you need to have a database. These are the three things. You have done database, right? So you have a database, you have a schema. The database is there, data is stored there. So you have the server, you have the backend. So what backend does is, whenever you query, it will send a query to the dashboard, the database, take the query data and push it to the server, and the server is going to show you here in the graphical user interface. That's what the whole process is. So let's look at how this works in R. So you have look at the code. You have several things. R Shiny dashboard and import the data. That's what we did separately previously without any dashboard. We have this code, import, read in the CSV, then merge and clean unused data, remove them. Then this is the user interface. So dashboard page, dashboard header, title, Superstore sales dashboard. That's the name that you saw in the dashboard. Then you have dashboard sidebar, category, choices, the choices that you make. So this is somewhat abstract, somewhat like it doesn't have any data, it's the visualization interface, UI. Then you have the KPI cards like fluid draw, changing, visualization 1, 2, 3, 4. All these things are just the abstract visualization. Then you have the server. Server has input, output and session. So input, at the beginning all categories are selected, then the filtration is there, category by input category. Input is the input that you make through the user interface. And the output, as the word suggests, is the output that server sends to the user interface, right? Then the bar chart style, everything is coded. It's just a script. Line chart code is there, scatter code is there, horizontal bar chart, donut, auto-generated text, everything is there. And the launching case, you launch UI and server to the Shiny app. So server code is there, UI code is there, the user interface. You send them in, and all the processing happens inside the server. That's the function. That's what it works. So whenever you do it in Power BI also, this is the thing that happens. Can be some variations, but this is the same thing that happens. You have the data, you connect the data to Power BI, do those visualizations, but you don't need to code them. You have those all the graphical things, and then everything is connected, the visualization is there. Python also, you have to do the same. You create a function backend, create the database, connect them, you have the dashboard. So it's a process. Now let's go to the lecture number 2. I will explain one by one. So this is going to be somewhat of an explanation rather than doing codes. The code part is the part that I just did. So let me, okay, it's recording. Right, I'll go quickly now. Since you I have an idea about what is happening, I'll quickly go through the lecture. Right, our Shiny our dashboard ecosystem and environment setup. I'll quickly go through the process. Right, learning objectives, understand the R dashboard landscape and the role of each major framework, like choose the right dashboard approach, set up a complete R and RStudio development environment, configure, build. So why R for dashboards? I have explained it. Technical skills, design principles, and real-world deployment workflows. So anybody can do R dashboards without much of. I mean, you need to know R, but if you learn only R. Now, I told you analysts are the people who become analysts after becoming experts or becoming aware of a certain subject. They all don't know programming in the same way. So some of them have learned R. Some of them have learned only other type of, say, just without any programming background as well. So for those people also, you can develop dashboards, and you can even upload this to POSIT dashboard servers, so you can easily share them. So this is very useful. Right. Now our dashboard ecosystem is in Shiny. So there are two types of dashboards, Flex dashboards and Shiny dashboards. Quarto and BSLIB, we don't necessarily talk about them because you need to know CSS. So Shiny runs on HTML, CSS or JavaScript. No, we don't need them. You just need R. R will do the rest of the things. And Flex dashboards also is an R markdown, ideal for quick prototypes, executive summaries, and periodic semi-interactive reports. So if you are planning to do your analytics practicum, for example, using some statistical techniques, even if it is like decision trees or some basic programming or let's say OR, if you are doing it using OR, R has a lot of OR functionalities, so you can use R and do everything and create a dashboard for your final presentation using R itself. Right. Shiny. So there are two core components. I have shown you UI, user interface, and the server. UI defines the layout and input-output widgets, the dashboard you see parts, and then the server contains reactive logic, processes inputs and produce outputs, like the kitchen. There is a kitchen, so inputs come in. If you ask for a salad, they are not going to give you just carrots and other things separately. They are going to create the salad, right? So input is there, input is the request, output is the output that you get. So reactive model, efficient computation through automation and clean separation. So all those codes that we develop, like previously before coming to the dashboards, we did some codes, right, previously. So we can put all of them inside the dashboards. So whenever someone wants to like merge the data, split the data, you can just put buttons, and each button will be a coded segment. So whenever you click on them on the UI, those things will be applied. Then Flex dashboards, they are quick, they display oriented interfaces, not primarily input collecting. They are just dashboards, like without any interaction. Shiny dashboards allow you to interact. Flex dashboards are like normal like visualization dashboards, they don't have any interaction options. Right. Quarto, the next generation, multi-language, R, Python, Julia, JavaScript. So we have multi-language in Quarto. Publication quality output with advanced configured theming. We'll not talk about Quarto here, but as you learn Python more, you can learn Quarto how to do it. Shiny dashboards with BSLIB built on Bootstrap. Up-to-date standard with BSLIB is more modern, we don't talk about it. Shiny, complex interactions, authentication, database API integration, or custom business logic. Shiny is easier because you know R, you understand what is happening. Quick builds, display only dashboards, R markdown based workflow. So if you are doing a visualization, just doing maybe company presentation, you don't want the interaction, then you can go for flex dashboards. Then Quarto, multi-language, BSLIB, right. So installing R and R Studio, we don't need to go into details, we know that. Package management, what is RENV? RENV, R environment. So now you guys tell me that you are more comfortable with Python. So in Python also you have environments. Have you not created an environment in Python? Yes or no? Anybody who has created an environment in Python? Done? Yes. Environment in Python. So when you install, you can install now. I told you about this when I did Python visualizations. Remember, we didn't use Anaconda. What did we use? Instead of Anaconda, what did we use? Miniconda. In Miniconda, it doesn't have those packages separately. Like it doesn't come with a bundle. So when it comes to Miniconda, what did we do? We install the base Python packages, then create environment for our work. So based on the work, we have for each environment separate things. Like if it is computer vision, we can have a separate environment for that and install computer vision libraries. If it is like spatial visualization, spatial data science, for that we have a separate environment and install that. So likewise, R has its own environment. So R environment initialization, in it means that initialize R inside the new existing project directory, install.packages, and R environment snapshot means it has that and it records all the packages installed into that environment. So whenever you load it, like you share it with a colleague or someone, whenever they load it, they just need to initiate this R environment restore. That's all. So in the zip file that I shared with you now, if I had this R environment, what you need to do is to restore that and all the packages will be installed back in that environment. That's what it does. Why it matters? Share R environment lock alongside your code. Any collaborator runs this and recreate your exact package environment across machines and time. So you are working with teams, it's very useful. You don't need, you don't like get a call maybe in the middle of the night asking it is not working, then it's because there is a package that you need to install. Like all the things are stored here. Right, we don't need to code here, but let's go forward. Essential package installation. This is what you need to do before running that app.r. You need to install these packages: Shiny, ggplot2, dplyr, R markdown. So if you have an error, you have to install these things. Now here I have done a different way of installing. So I have created packages and create a C file. C means inside this you have all the packages that I need separated by a comma. So that's like a string containing the name. Then I can simply say install the packages. So it's very easy. You don't need to type in all the things again if you have this. Right. Then React Log, Profviz, Styler, these are the development tools. RStudio workflow day 1, visualize your reactive grabs and runtime, no need to worry about that. So RStudio configurations, project structure, this is important. Now I have shared with you directly app.r, that is the entire thing having UI, server and all the processing logic. But you don't need it like that. When you are doing it in Python, you will realize that when you are developing the project, you have to separate them, like UI separate, backend separate, like the database separate, like that. You have separate code. So app.r have several splitting. You can do it UI.r and server.r. Separately, you can build the code. So that way also, this is the more professional way. Rather than having a single app.r, you have a UI.r and server.r separately. So hello shiny.r and run. I'm not taking much of time, so we are almost done a lot of work. So you can open this hello shiny.r and run, and there is a hello shiny in your folder. You can open it and run. Before that, you need to install those packages, these packages, and then run it. You will see a very nice figure there as well. So that's the end of the second lecture. Then the third lecture is fundamentals and reactive programming. So this is where reactive programming comes. In order to understand reactive programming, you need to have an idea about the workflow. It's like this. Now let's say, have you seen how pizza guys prepare pizza? Pizza Hut or Domino's. Are they having the are they preparing the dough and everything from the scratch when you go to Pizza Hut? They have dough separately, cheese separate, right? Mozzarella, like the base is there, and every time you have it, you have separate things to add. So reactive programming is like that. So in order to program it, you need to know how things work in an abstract level, and then you process it. So you know which one you need, the organization is there, based on that you code. So UI is coded based on what you want, and the input and the output are like the reactive source inputs emit new values when the user interacts with the UI. So you need to know what the user wants. So if it is an analysis, if it is like, for example, for a data visualization like this, let's say you need the products ID, location, likewise what the user might want to interact it with. So that is there. Reactive conductors, expressions, perform and cache intermediate computations. So you don't need to memory management is also there. Let's say someone wants to, first of all, let's say Western Province, there are province wise data. Someone filters Western Province first and then look at Colombo. Then if that person is going to select Gampaha, you are taking from the cache memory of the Western Province rather than going through the same process. That's what it means. Right? You need to understand the level of you don't need to re-cache everything. Right, display final results, update. So all these things work in the computer. That's the beauty of computers. Like even if it is 10,000 lines, all of them work when you interact. That is the beauty of it. But that happens in a millisecond or 2 milliseconds or something like that. It's very fast for us. But all those things happen. That's why when you get an error, in Python you get an error line number 132 return with the HTTP error, and then you go to the error, then it shows the base package error or something. Some very awkward error is there because it goes to all the lines inside those packages. So if there is a compatibility error, it also shows that this was built with NumPy, this one, this has to run with this. So all the incompatibility things are also there because it is line by line. But because computers are very fast, you don't feel that. That's the thing. So here also all these things happen, but within 1 millisecond, 2 millisecond. They are lazy by design. Chinese reactive model is lazy, computations execute only when needed, and cache results until a dependency changes. That means the Western province example that I gave you. If you select Western province, it loads Western province. Unless you say you load Western province and if you want to select something like Pathadumbara or something, it has to load everything again to go to Pathadumbara. But until you work in Western province, it keeps the Western province loaded. It's lazy to load anything else. That's what it says. Right. The reactive sources, conductors, endpoints are there, and the UI server architecture, input read-only list of all current UI control values, output and session. So the codes are there, Data Explorer, all the codes are there in the folder that I shared with you, so you can play with them. UI definitions, server logic, everything is there. So common input functions, text inputs. Okay, now here's the thing. When you learn something, first of all, try to scaffold. Scaffold means don't try to learn everything about it. Learn something simple about it and learn it better. Then try to scaffold. Try to include new things like an onion. So there are more functions. Like there are many other functions, but these are common functions. If you learn them, it is easy for you. So what are the things? Text inputs. You basically put text inputs into your dashboards. Then slider inputs. You slide values, right? And then you have select input, selecting the drop downs. And then you have file input. You put a CSV file to it or a whatever text file to it. Then checkbox. Checkboxes are there. Tick, tick, tick. Those things are there. So these things would be enough for you to develop any decent dashboard. But if you learn them well, you can actually find more functions, fancy things. But that is the problem. Now, this is not related to lecture, but what I see with undergraduates, I'm not taking master students to this because it's not fair. Let's take undergraduates for example. If you give something to them, they don't learn the essence. Now I'm talking about nowadays, right? I'm not really criticizing them, but this is a problem. They go to an AI tool and ask for this, and the AI tool is going to give them the most sophisticated answer. I'm sure you have seen this. If you want to get a Python script and you just type it in Claude and ask for a solution, it will give you a developer level answer, right? With all the conditions in it, the program works like smooth. It's really flawless. But that doesn't help the learning process, because you don't learn anything by like simple way. If you bring that code and say second year student bringing a developer level code, but then if you are bringing it, you should be able to answer that, right? If there is a question like, okay, if I want to change the parameters of this and that, how do you do it? Then you take it back to ChatGPT or something and then come back with the answer. But that should not be the process. If it is a simple thing like I did this, and how do I change it, you move from there. It's very simple. But learning has to be like that. If you learn it for 3 months, 4 months, then going to the advanced level it's totally fine. That's what I say. So if you want to learn this basic, like if you want to develop our dashboard for example, learn these 5 things and how to interact with them, change it by your own. Using ChatGPT or Claude is totally fine. Use them and just try to learn how they behave, how a text input behave. If I give a number to the text input, does it take it as a number? Does it take it as a text? Right? So those are the things that you have to worry. Ask the questions, learn the simple things better. That's what I say. Use AI by all means, no problem. But learn it better. If you learn it better, simple things deeper, after a certain time, it's easy for you to scaffold, right? You know the basics. So it's easy for you to move from there. So these are common input functions and common output. So these things would be more than enough. And reactive expressions are there. Let's go quickly. Debugging Shiny application, we don't need that. Side effects and isolate, so some codes are there.